Welcome to the workshop. We want to continue taking a look at section 2.4, functions, and we're going to consider some additional definitions that you may not be familiar with. All right, so our first definition is a function is said to be one-to-one, which can be shorthanded 1-1. A function is said to be one-to-one if no two distinct elements of the domain are assigned to the same element in the codomain. All right, we'll look at a nice image of this in just a moment. And to show a function is one-to-one, one must show that the outputs being equal, f of a equals f of b. Okay, so if two distinct elements of the domain are assigned to, no two elements of the domain are assigned to the same element in the codomain. So if two elements are assigned to the same element in the codomain, then those two elements would actually have to be the same thing if it's one-to-one. Because if a were not equal to b, then f of a would not be equal to f of b. That's what this line says here. So this says if a is not equal to b, then f of a is not equal to f of b. So let's look at a function that is one-to-one, using a nice diagram to help us out. So let's say I have my domain A and my codomain B. All right, and let's take a look at several elements in A. So let's say I've got 1, 2, 3, 4 elements in A, and 1, 2, 3, 4, 5 elements in B. So for a function to be one-to-one, if we take two different things in the input, right? If we take two different things in the domain, they have to be associated to or related to two different things in the codomain. So let's say this guy goes to that one. Okay, now any of these other elements in the domain simply cannot go to that one as well. Okay, we're going to two different inputs have two different outputs. Still true, two different inputs have two different outputs. Again, two different inputs have two different outputs. None of the outputs are repeated. There's no two arrows going to the same element in the codomain. All right, so just for clarity, let's take a look at something that is not one-to-one. Still a function, but not one-to-one. So let's take a look at this. So again, let's say I have my domain and my codomain, and 4 elements in the domain, 5 elements in the codomain. So let's say I've got this. Take a look at our function f. So I could have the same thing here to begin with. This element is related to that one. And let's have this one be related to that one. Everything looks fine and dandy so far. But as soon as I repeat things, I have a problem. Because these two, right, the problem is this right here. This element of the domain and this element of the domain, they're distinct elements of the domain that have the same output. This is not one-to-one. 2 elements here associate to 2 elements here. 2 elements here associate to 1 element here. Not one-to-one, one-to-one. Okay? All right. So hopefully that clarifies a little bit about what one-to-one is. And as far as showing what one-to-one is, if we have something that is one-to-one and we take 2 different outputs, let's just use black here maybe. If we use 2 different outputs, f of A is equal to f of B, then when we trace it back, we find that A and B are not equal to one another. Cool. Over here, if I have that f of A is equal to f of B, okay, if I have f of A is equal to f of B, it's not necessarily true that A and B are the same element. So A and B go to the same element here. A and B go to different elements here. If we assume that these are equal, then they would have had, if we assume that these are equal, f of A equals f of B, then I guess I labeled this wrong. If we assume that these are equal, then they would have had to been the same thing to begin with. Okay. Here, if we assume that they're equal, it is possible to get two different inputs. All right. Yep, okay. So let's go to one additional definition then, before we look at some examples. So the set of images of all the elements from the domain is called the range of the function. That is not new, but what might be new, right, since we introduced the idea of a codomain, what we want to do is we want to see how these two things are related, or at least one of their interactions. So a function is said to be onto if the codomain and range are equal. So when the codomain and range are the same, that's a special function, and that function is called onto. To show a function is onto, we must show that the codomain is actually the range. So we must show that if we have some element in the codomain, that it is in fact part of the range. So here's something in the codomain, then there is an element in the domain such that y is equal to f of x. Okay, right? If it's onto, then the domain and range are equal. So we want to show that the domain, we want to show that the codomain is in fact the range. So we take something from the codomain, a generic element, and we show that there is something in the domain that has this as its image. All right, so let's look at just a quick visual representation, a diagram that shows what onto is. So let's say we have our domain and our codomain, and we have several elements. In our domain and codomain. So let's say we have our function f. Okay, so let's say we got that one going there, this one going here, and that one there, this one here, and this one there. Excellent. So it's a function because everything in the domain has an image, and it's onto because everything in the codomain has a pre-image, right? It is the image of something from the domain. So to further clarify, let's take a look at something that is not onto as well. Our domain, our codomain. And let's take a look at the same sort of situation. 5 elements over here in our domain, and 1, 2, 3, 4 elements in our codomain. And we want to look at an example where it's not one-to-one or not onto. So that just means that there's at least one element in the codomain that is not the image of something from the domain. So here the problem is exactly this guy, right? It does not have a pre-image, right? It is not the image of something from the domain. It is not part of the range, right? This element is not part of the range. So B is not the range. The range is some subset of B. So this is not onto. Okay, if the codomain and the range are equal to one another, if they're the same thing, then it's called onto. This is not onto, right? A maps onto F. It covers all of F. Sorry. A maps onto B. It covers all of B through F. In this case, A does not cover all of B. It is not onto B because it doesn't cover up this guy. It's not onto this element from the codomain. All right. Hopefully that has clarified things in terms of what one-to-one and onto are. So in our next video, we'll take a look at 3 examples and we'll show whether the function is or is not one-to-one or onto. Okay, so I'll see you guys back in the workshop very shortly.